Hello everyone. In this video, we will study a curve called cycloid generated by a circle radius A, and we will find the parametrization for this curve. So let us start with what is a cycloid, or the cycloid generated by a circle radius A. So this, to define it, fix a circle radius A. So consider a circle radius A rolling on a straight line with constant speed. In other words, if I want to draw you a picture, I have something here to show you. So let's say at time t equal to 0 is this, and then it starts rolling, and while it rolls, we move forward. Yes? Well, now consider at time t equal to 0, the point at which the circle touches the ground. And as time passes, this rolls, the point goes up, and then start going down and back to the ground. Yes? So if you trace the locations of this point, that will define you a curve. That curve is called the cycloid generated by the circle radius A. So the trace of that point form a curve called cycloid generated by a circle radius A. Okay, so it's periodic, it repeats itself, and we don't have any other curve defined. Well, this is the first time we're seeing this thing. Yeah. Now, the question is, we need a parametrization for this to be able mathematically describe parametrization for cycloid. So, to be able to write a parametrization, we have to see that the moment of the point comes from two things. One is the rotation of the wheel. Okay, comes from rotation. It means that if I assume that the center is fixed, then just looking at what is rolling, you notice that this point goes around and around and around. Yes. The second thing is the displacement, or maybe I should write it here, displacement of the center. Okay, so for the rotation, the only thing you need to keep in mind is that, okay, so that at t equal to 0, this guy is down there. So if I put that in a coordinate system, it will show me like that. Yes. And if we want to parameterize again circle by t, it starts with negative pi over 2 and goes clockwise, starting from negative pi over 2. Okay, so then that means that I can go ahead and use the parametrization I know for a circle. So a cosine of something, y a sine of something. Now, since it's going clockwise, so it is, in other words, the opposite direction of the standard counterclockwise direction. It's clockwise, that means that the coefficient of t must be negative. It starts from negative pi over 2, so you can just write it like that. So this will describe the movement generated by the rotation. But I can simplify this a little bit, use the formula for cosine. This will give us cosine of negative pi over 2, cosine of t plus sine of negative pi over 2 times sine t. Well, this piece here is 0, this piece here is negative 1, so that turns out to be negative a sine t. The same kind of argument works here. Remember the formula for sums or differences of two angles. You expand that and you find the terms which are related to negative pi over 2, and what you will find is a cosine t. Well, that is the rotation part. How about the displacement of the center? Because it is important now to see how the center moves, yes? For that part, you need to see that the center moves with constant speed. So that means that x is going to be the speed here times t, and y, well, always stays on the same height, always a, yes? Now, for us, the important thing is that what is that speed? Because we already have a parameter for this part. Well, finding that speed is not difficult, because when you roll the circle, at t equal to 0 was here, at t equal to 2 pi was back there again. The distance moved by the circle, or by that point here, is the circumference of that circle, which is 2 pi a. The time taken to do this is 2 pi. So then the speed at which the center moves is the distance divided by the time. So 2 pi a divided by 2 pi, this is a. Yes, we found what is that speed if that parameterization is true. So we have now everything set up. We have the displacement of center, the rotation. Together, we have to add them to find the parameterization. For the first one, we have a times t here. For v, I put a minus a sine t. And y is a minus a cosine t. And that is the parametrization of the cycloid generated by a circle radius a. Well, you can simplify that and write it as x equal to a t minus sine t, and y as a 1 minus cosine t. Okay, so this you have to know, and you have to be able to use it when you need it.